Thank you, Maggie, and welcome everyone to today's NRCS Biology webinar. Today's presentation, Creating and Restoring Safe and Accessible Water Resources for Livestock, Bats, and Other Wildlife, will be presented by Dan Taylor and Stu Tuttle. It represents a need that was identified by you, the NRCS biologist, and I'm very appreciative for Stu and Dan presenting what I think will be an excellent webinar for us. Stu?
Thanks, Bill, and good afternoon or good noon or good morning to everyone, depending on where you're sitting. I'm in Flagstaff, Arizona, so it's 11 o'clock my time. I really appreciate Dan agreeing to do this. He's our main speaker today. He's a whirlwind of activity. If any of you know Dan Taylor, you'll know he's hard to keep up with. He's all over the place. And he's done a lot of work for the last about 8 years on this Water for Wildlife program, and I was kind of there at the start of it with him, so that's kind of how we connected. Here's kind of what we're going to go over. Most of this is going to be through Dan. He's going to talk about the issue, what it is that we're talking about today, which is the distribution and safe availability of water for wildlife. He's going to go a little bit into basic water needs, including a nice session on bats. If you don't know much about bats, you're in luck today because Dan's got a great presentation on that. And then we're going to go into a little bit about livestock water needs and how the bats and other wildlife and livestock watering points are connected, and a little bit more into how those facilities are out there on the landscape through troughs and ponds. Dan's been doing some neat work of late, concentrating more on ponds and trying to make them more wildlife friendly. And then he's going to talk a little bit about obstructions and escape ramps and those sorts of things that we've been working on for the last 8 years. And I will wrap up with a few slides about how all of this information has changed our standards through time. So I'd like to introduce Dan Taylor. That's a couple pictures of him there. He has his BS in wildlife biology from the University of Montana, and he and I got our master's degrees from Northern Arizona at the same time. He was in forestry. He was the first director of Belize's Coxcomb Basin Jaguar Preserve while he was in the Peace Corps. He basically built the preserve and got it going, and it's still going today. Really the first preserve that was ever established in Belize, so he's got a good history there. He was a wildlife biologist through several different forests with the Forest Service in Montana, Oregon, and in Prescott, Arizona. And for a few years he directed the Bat Conservation International Forest and Abandoned Mine Lands programs. And 8 years ago, approximately, he became the Water for Wildlife program coordinator. It was a new program established at that time for Bat Conservation International, and that's where he still is today. So with that, I'll turn it over to Dan, and you can get started. Take just a second to...
My slide on the... You guys got me?
Yeah, Maggie took over.
Okay.
Hold on just a second.
All right. For some reason, I'm showing my slides, but I'm not seeing them on the screen.
Dan, I'm going to pass your presentation right now and ask that you please double-click to confirm.
Okay.
Thank you.
There you
got it. All right. I'm still not seeing my main presentation on the screen.
Well, you'll need to click on that.
I've done that. Any other way to get that to come up? Okay, here we go. Can everybody see that first slide?
Dan, if I can ask you to expand your deck and double-click on the first slide within it, that will refresh us for those in the audience.
There we go. There we go.
I see it.
Okay. All right. Good enough. Thanks. Can everybody hear me okay? I'll assume so.
Loud and clear. Thank you.
All right. Great. Thanks, Stu. All right. Well, today, as Stu mentioned, we're going to talk about providing safe, reliable, and accessible water sources for livestock, bats, and other wildlife. And I think as we go along, you'll understand what safe really means, what reliable means, and accessible. So that should be pretty obvious. Okay, so I think the other thing is, of course, because I work in the West and mostly in the West, this will be West-focused, but I do think a lot of this information will be applicable to the central, northeast, and southeast U.S. as well. But I will start by saying in the western U.S., where it's more arid, there's really been a precipitous decline in the availability and distribution of water and associated habitats, riparian habitats, over the last 50 to 150 years. Some of the estimates are as high as 70 to 95% of all riparian habitat and natural water sources have disappeared in that time. So obviously it's a big concern for wildlife, for livestock, for people. Water is the lifeblood of the planet, and probably don't need to belabor that, how important it is. But another important thing to mention is in between 2003 and 2007, the 11 western states experienced 70% more warming than the average global increase in the entire 20th century. So basically, the West, and particularly the Southwest, have heated up. Temperatures have increased. Precipitation patterns have changed more than anywhere else on the planet. And it really doesn't look great for the future, the immediate future. Things are going to get warmer, and they're going to get drier. So water issues are going to continue to be extremely important. Well, some of the places then on the landscape where we have water, slide out of order. Okay, we're back. Whiplash. Well, anyway, all, of course, but the most desert-adapted species of wildlife need water. And there are animals that are desert-adapted but will still need water during reproduction and lactation. There are wildlife species that get a lot of water metabolized from their prey, or if you're a pronghorn or a deer, you may need less water when there's a lot of water in vegetation you're eating. But when things start to dry up, or again during reproduction, those water needs really increase. So where is it on the landscape, both east-west? It's in rivers, of course, which are perennial. Most rivers are perennial still. The creeks and springs, reservoirs, ephemeral sources. Now rivers in the West are kind of far between, scattered on the landscape, as are creeks. Reservoirs are important sources of water, but they, again, are pretty far apart, spaced on the landscape. Talk about later, there are some bats that will actually fly quite a distance, Eumomyotis and little brown bats, to forage over reservoirs, but it's just not a very common feature on the landscape. There are ephemeral sources, vernal pools, tanajas, playa lakes that fill up during the winter rains, but a lot of these sources dry up when wildlife needs it most during reproduction and lactation. So there are a lot of natural sources. They have been disappearing, but most of these sources that we're looking at, creeks, springs, rivers, reservoirs, ephemeral, they are fairly well scattered and distributed on the landscape. All right. Over the last 40 years or so, state wildlife agencies started to build wildlife water developments. There are probably between 7,000 and 10,000 of these across the West. They're often ephemeral, meaning if they're catching rainwater or guzzler, they will last for a little while until the water evaporates away. They are game-focused normally, bobwhite, mule deer, bighorn sheep, especially elk. So guzzlers have really been focused on game species. They are usually placed in target habitat, so that does increase their value to wildlife. Since we're putting the water out there in the landscape, often we'll put it in a place that has good habitat, but that might be water limiting. But however, when you start to look at the numbers across the West, it really isn't a great effect on the landscape scale. Now, part of the reason that this presentation is going to focus on livestock water developments, at least initially, is because there are tens, if not hundreds of thousands of livestock waters over the last 100 years that have been developed, and these are well distributed across western forest and rangelands. These are things, of course, like stock ponds, troughs, different types of drinkers. Now, these can be ephemeral when people shut water off to move cows between, manage livestock between pastures, but normally, and then stock ponds especially, would be a seasonal source of water unless they're especially large or deep. But normally these are fairly reliable sources of water because they are coming from wells that are piped out to the troughs through a pipeline. And, as a wildlife biologist and when I was a Forest Service biologist, rightly so, we focused heavily on riparian areas and natural water sources and really ignored these water sources in terms of a source of water for wildlife. And I think that's still in some cases what's happening today. And if you think about it, this much water distributed across the landscape at a time of drying climates, wildlife doesn't distinguish between a livestock water and a natural water if they're going for a drink. It's just water. So hopefully people will start paying more attention to livestock and range water developments in terms of their value to wildlife. A couple illustrations of this and examples. There was some research done in northern New Mexico, also at Wapopte Crater in northern Arizona, and some of these water sites, livestock waters, will actually be used preferentially over natural water sources. And what's going on there is if you're an animal, let's say with a large home range, and you're looking for water, you may go to a windmill and a stock tank because you know that water is going to be there year-round, rather than make the trip to a wash that's ephemeral or a stream that may be dry, intermittent half of the year. So, and this was some research. These camera traps are just showing some pictures that were taken on the Carson National Forest, and they, recorded rates of one bear every 7 days, one elk every 4 days, one lion every 7 days. So a lot of wildlife use of range waters. I like this next series of slides. I think this shows it as well as anything. This is just a livestock trough down on the border in Arizona, close to the Mexico border. This is in 1 month with a camera trap. You can see a lion at the water. White-tailed deer, Coues whitetail. Quadamundi, missing his tail for some reason. Javelina, and you can see the young javelina certainly cannot reach that water, but they know it's there. They can smell it. There's the gray fox. This is the night shift. That was the day shift. Now the night shift. Bobcat. Great horned owl. And undocumented aliens. So this water is important to all types of wildlife and humans. And you can see it's a livestock water. It was put out for livestock management, but the wildlife aren't paying that any particular attention. And we can come back to that, take a look at that trough with the wires across it and how it's raised up above the ground, and easily kind of jumping ahead here, but you can see how it could be made a lot better for wildlife. All right, now why bats? Bats are particularly dependent on free water, especially pregnant and lactating females, because they're a small-bodied mammal that flies. Their physiology is such that they can lose up to 30% of their body weight in a single 12-hour period. It says afternoon, but in just a half a day. And a lot of parts of the country, the east, the center part of the country, the northeast, northwest even, roost, the common thought is that roost are limiting bat populations, caves, old trees, mines, places for raising young. But in the southwest, water availability is probably the main factor limiting distribution and abundance. I should mention on a pretty neat study done by Rick Adams at Northern Colorado University, he was following a colony of fringe-tailed myotis, that's Myotis physinotes, for a decade, and knew that this was the only good-sized colony in the canyon he was working in, and he pit tagged the animals, a small metal tag the size of a grain of rice, and he put the pit tag reader in the only pool of water left in the canyon. There was most had dried up, and he covered up the other two. So when the bats came down to drink, he knew exactly which bat it was, the age of the bat, well, juvenile or adult, male or female, and could record how often they were drinking. And he saw that the females had 13 times, the reproductive and lactating, pregnant or lactating females had 13 times the water needs of the non-reproductive or males. What got him published in Ecology was he tied that in to climate change models showing a drop in stream flow, predicted drops in stream flows, and estimated some fairly large precipitous declines in reproductive potential of bats in the West based on declining stream flows. All right, now the other thing about bats and livestock water development is bats have to drink in flight. So they swoop down and use their lower jaw or their tongue to get a drink. So if there's a seep out there and a pronghorn or grouse can just put its beak or lips down there and drink, that's fine, but that won't work for bats. You have to have pooled water or very slow-moving water. So certainly they'll drink from slow-moving rivers or in an eddy or a slough. But basically they need pooled water. And again, livestock water developments are almost always a pooled water source. But, the big thing when I'm working with ranchers and range and wildlife managers, a lot of them, want to know what the heck, why do we care about bats? It's pretty easy to explain deer and elk management. It's so ingrained and it's important to the economics, and, of course, you can eat them. But, often then I'll put in a little background on bats. I won't even advertise it. I'll just kind of stick it in the slide presentation so they'll have to sit through it. Now, most of you, there's some range folks here and biologists on the line, but I'll just go through a brief background. There's definitely some things in here I don't think people are aware of, even people that are pretty up to speed on other wildlife taxa. The first is that for their size, they're the slowest reproducing and longest lived mammals on the planet. I think 46 years is the current record for longevity for a little brown bat from Vermont. I think 10 to 12 years is probably an average lifespan, but there's certainly bats in their 20s. And then you're having one pup per year on average. There are some species that have more young, but basically when you live 20, 30 years, 40 years, and you have one pup per year, one young per year, that's a pretty slow reproductive rate. And conservation are actions that knock those populations down. It takes a long time for them to recover. Some of the things people do, most people know is they have a very sophisticated echolocation. There's a diagram, a representation. The sound is produced through the larynx, bounces off other objects in the environment, including their prey, comes back to the bat's ears, and is processed by the brain. I'll just say that it is still faster than the world's greatest supercomputer, though I'm sure the computer is catching up. They process an incredible amount of information, and they do it very, very, very quickly in nanoseconds. The Navy has been studying bat echolocation for probably 25, 35 years, as well as other scientists to try and understand. The last interesting factoids are that they do believe they may be forming a three-dimensional image of sound because there's parts of their brain, the oral and the visual, the aural and the visual are connected in such a way that they believe they're using sound in the same way we would use vision. But they also do have good regular vision. In the lower right picture is a California leaf-nosed bat, and this bat has night vision equivalent to good military night vision, and it can also hear, not with echolocation, just its ears, the footsteps of this beetle on the sand from several feet away. So excellent hearing as well. So pretty neat mammal, very well adapted for what it does. Chiroptera is the order they belong to, so that means hand wings. So you can see that the bones in the wing are analogous to it's the same as our radius and ulna and our fingers, with a couple layers of skin over top, and they are the world's only true flying mammals. And there are over 1,200 species. That's a quarter of all the mammals on the planet are bats. And in this diversity of species, there's a huge diversity of morphologies, from these old-world fruit bats with 5.5 to 6 foot wingspans, as you see in the top left corner. Don't recommend trying that at home. Down to Kitty's hognose bat from Thailand, which weighs just a little over a gram. The shrew biologists argue with the bat biologist who has the smallest mammal species in the world, but this little bat is definitely tied for the smallest. And there's a lot of really interesting-looking bats, large ears that play into the type of echolocation they use. This is a ghost-faced bat from Australia on the left that eats mammals. A spear-nosed bat from Central and South America. That leaf on the nose helps direct echolocation, functions in the type of echolocation. Horseshoe bat from, I believe that's another Australian bat. And Chapin's freetail from Africa, that's a little mating crest for when they're mating. And the spectacle flying fox, old-world fruit bat from Australia. Looks like something you would want to ask your mom if you could take home when you were a kid. And then there's some really bizarre-looking bats. This is the wrinkle-faced bat from Central America. Caught a few of these this winter helping somebody in Nicaragua. They are really strange bats. Stu was down there, too. And this is a fruit-eating bat, and that's what they say. I don't think so. I think they need to do a little more research. I think they're eating things that move around more than fruit. This bat is so ugly, when it courts, it has a flap of skin under its neck that it pulls up over its face with 2 translucent windows to look out. So, really interesting bat. And then there's some bats that are just kind of goofy looking, but this one has actually got its cheeks filled with fruit. This is an epilated bat from Africa, and it will fly back to a feeding roost where it's safer from predators than if it was feeding in a tree. All those bats feeding in a tree attract a lot of attention from predators. So you can see there's this really neat morphology, and this is also reflected in what they eat. This is a fishing bat. Its echolocation calls pick up the ripples on the surface of the water from a minnow's fin, and then it has really big claws in the back, and they use those to gap the fish, and they pretty much swallow it whole. Pretty neat bat. And then there is the frog-eating bat. Specializes in frogs, but does eat other organisms, and it can tell the difference between poisonous and non-poisonous frogs from their call. And the frogs, you have to call to get a mate, but if you call too loud, you might get eaten. So the frogs often will call by something like a waterfall because it has a high-frequency sound that helps jam the bat's radar. Vampires, yes, there are vampire bats. They're not found in North America, or the U.S. anyway, up to about central New Mexico, though there have been a couple papers recently on climate change and range expansion. So you NRCS people in Texas maybe pay attention, or at least your kids will be paying attention to what vampire bats are doing. There's 1 bird specialist and 2 that feed on birds and mammals. They probably were an uncommon bat. The common vampire, this one in this picture, before settlement by Europeans of Central and South America, because it's a lot easier to get a blood meal from a big, slow pig or a cow than it is to get one from a jaguar or a monkey or a tapir. But they make a couple little incisions, and they have an anticoagulant in their saliva, and then they'll lick up the blood just like a cat would lick up milk. They can drink up to 50% of their body weight in blood. They start urinating immediately to get rid of the excess salt, because we all know there's a lot of salt in blood, and they can also run pretty quick. So if the horse starts walking away or the cow, they can continue to run alongside and feed. Neat little animals. At least I think so. All right, but it's probably 70% of those 1,200 species of bats eat insects, and the great remainder pollinate flowers or eat fruit or nectar, and this is where we really start to see the economical and ecological benefit of bats to humans. In the tropics, in West Africa, in South and Central America, you hear about slash and bird agriculture, but any time a field or tropical forest is cleared, somewhere between 70 and 90% of the first seeds that end up in that field are carried there by bats. This Corolla, short-tailed fruit bat, can disperse 60,000 seeds a night per bat. These are small seeds of this piper plant, which you can see in the bottom left and the bottom right. That's 3 years of growth in that field. Birds are important too, but they tend to disperse seeds a little later in the succession process. So extremely, extremely important to reforestation. Pollination, here's an example, of course, right here from the U.S. This is in the Southwest. The lesser long-nosed bat, which is an endangered species found into southern Arizona, southwestern corner of New Mexico, and then they extend down through Mexico into Central America. They pollinate the flowers of large columnar cactus like saguaro and cardone and organ pipe. You can see this bat approaching the flower. Flowers that are pollinated by bats are held away from the plant. This is what's called a bat flower syndrome. They're often light-colored. This works for moths as well, and they put their nectar out at night. You can see how the bat's head fits right in the flower, the saguaro flower, and the pollen all over its face. And, of course, saguaros are important, the fruit as a source of food for a lot of other animals, javelina, deer, as humans as well. The Tahoe O'odham people rely on saguaro fruits. And then, of course, they pollinate the agave, the wild agave, that tequila is made from. So no bats, no tequila. Actually, a lot of the tequila is grown in commercially in plantations now, but some of the wild tequila, the wild agave, pretty wild tequila, the wild agave that makes pretty wild tequila is also bat pollinated. Okay, in North America, of course, those we only have 2 of the nectar bats out of our 45 bat species in the U.S. and Canada. So all but 2 of those are insectivores. And again, economics here is really pretty straightforward. This is a common big brown bat. They're found across the U.S. and Canada. John Whitaker at Indiana State did some research on these, and an average colony of 150 females ate 32,000 cucumber beetles in a summer, and those cucumber beetles would have produced 30 million of these corn earworms. So a pretty direct value to agriculture, forestry as primary predators of night-flying insects. This is the Mexican free-tail bat. It's the bat that's under the bridge in Austin. The same bat that is in Carlsbad Caverns. It's found across the southern half of the U.S., forms very, very large colonies, the most dense aggregation of mammals in the world. Raccoon Cave, where these bats congregate, which is owned by BCI, but there are several large free-tail caves in the southern U.S. This is in southern Texas. Has between 10 and 15 million bats. And those bats eat 400,000 pounds of insects in a single night. Most insectivorous bats can eat almost their body weight nightly in insects. There's some pretty neat research that started about 10 years ago, maybe 15 years ago, where they noticed these bats were foraging up at 14,000 feet, a couple miles up. They wondered what was going on. What were they feeding on? Well, it turns out they are feeding on migratory flocks of moths that migrate up from Mexico. Those populations touch down in central U.S. kind of hopscotch up into the bread belt. Those are army cutworm moths, Heliothis moths, several other species that are have a huge effect on agriculture. Attack cotton, soybeans, corn, squash, tomatoes. So recently, with the advent of white nose syndrome killing bats in the Northeast, some scientists worked pretty hard at quantifying the economic benefit to agriculture in the U.S., and they came up with about and this is a very rigorous bit of work, $3.5 billion in savings in pesticide use and material saved, plant material saved, because of predation by bats on the primary insect pest of these crops. So a huge, huge value. I should mention one other thing just because it's so damn neat, is there's a woman from UC Santa Cruz, Winifred Frick, and has been working. It turns out all the Doppler radar stations in the U.S., and they're all over, they screen out bats and screen out birds when they're doing weather estimates, and they have programs that count the number of water droplets in a cloud, these estimators, quantitative precipitation estimators. And now they're using that technology to count some of these bats, to track some of these bats at high elevations. And it turns out insects will pull up along the front of a cold front, along a line, just like along an eddy in a stream, and the bats will trap line the insects flying along the line of insects formed by the cold front and trap line and eating up insects. Pretty neat stuff. Okay, so some of the bats we have here, and some of my favorites are the shell-rear bats of our 45 species. This is the pallid bat from the southwestern U.S. These bats tend to prefer scorpions and centipedes. They are immune to the stings of scorpions, so when we catch them, they often have, one bad eye and holes in their ears and such. But they're a neat bat. They land to grab insects, grab them off the ground. This is the hoary bat. This bat is found throughout the United States and Canada. It is a long-distance migrant. It roosts in trees, in pine trees, deciduous trees. This bat is actually the main species being killed by wind turbines. So if you have wind power projects, this is a species you want to learn a little bit about and pay attention to. They're killed during peak migration. Still a lot of work. BCI has if you go to batsandwind.org, you'll find all of the research you probably need for input on wind power. There are a couple other migratory species that are killed way more than others, too, by wind power, the red bat, which we'll see here in a second, and the silver-haired bat. But these are really neat bats. They're large bats. They eat large beetles. They have been known to eat even smaller bats. And the males and the females are often separated in different parts of the country at different times of the year. This is the red bat, another migratory tree-roosting bat. There's an eastern red bat and a western red bat. This bat is still one of the more common bats in the eastern U.S., not as common, the western red bat in the west, but a prolific predator of moths, really in the west associated often with mature riparian cottonwood forests, sycamore, mature riparian galleries, which of course have declined quite a bit. Some neat work done by Bureau of Rec. They're researchers on the lower Colorado. They were doing mitigation, replanting cottonwoods. The only land they had were in squares next to the river, not along the river, but they irrigated and planted these cottonwoods, and when the cottonwoods got about 15 feet tall, the bats started using those cottonwood stands. So it's kind of neat. They used bat detectors and very robust data set, hundreds of thousands of bat calls and collected to monitor activity, but there was an absolute direct correlation between the recovery of these cottonwoods along the river and the presence of these bats. All right, this is the big-eared bat. I think we have one more after this. Also listed as state-sensitive in much of the West. There are other subspecies in the East, Virginia big-eared bat that is endangered, Ozark big-eared bat, which is endangered. This is Townsend's big-eared bat from the West, There are a couple subspecies. None of them are considered endangered. All these species are mine and cave obligates, though for summer colonies, some will use buildings in the west and the east, but caves and mines are typically thought to be limited to these bats. And of course, but in the drier habitats, again, water would be a limiting factor. And those large ears tell you that it's a whispered bat. It has a very quiet echolocation, which it's using to try and sneak up on the moths, which reminds me of another study that they did that I didn't mention with the Mexican free-tail bats, is that they played randomized bat calls over test, control and non-control soybean and corn fields on the coastal plains of Texas, and they found just by broadcasting the bat calls, crop damage was decreased 50%. Part of it was because, of course, the bats, some of those moths have developed ears that hear just that frequency produced by the bat, so they will abandon the area or hit the turf trying to get away. And also those calls brought bats in, almost like a decoy. They heard feeding going on. They wanted to see what was happening, so more bats would come in. All right, the last bat we have, before we start talking really the heart of the presentation on water developments and wildlife, is the spotted bat. This is kind of the holy grail for bat catchers in western North America because it's such a beautiful bat. Black fur, white spots, striking large pink ears. These bats are up in high elevation meadows in canyon country like the Grand Canyon, Big Bend, Sierra Canyons, California, but pretty much found across the West, just never at high densities. They're an audible echolocating bat, meaning we can actually hear their calls, kind of like a little chirp, a tinny chirp. These bats, Carol Chambers at NAU, I know Stu was involved with the study as well, and others followed these bats. They would fly 25 miles. This is like a 15-gram animal, and they would fly 25 miles from the walls of the Grand Canyon to feed on moths, on the ponderosa pine stringers, these big saturnid moths, and then fly 25 miles back for the roost for the day. The only other thing that was pretty darn cool is there's a cave on Navajo Carol has done work at, Dr. Chambers, and there are bat mummies in this cave. Now, this is usually a crevice roosting bat, but this cave seems to attract a lot of males. And there were some mummies that they carbon dated, and some were 50 years old, and some were 8,000 years old. So these bats have been using this cave for at least 8,000 years, which, of course, also has its own conservation implications for cave and vine management. All right, so bats need a lot of water. Now we kind of get to the cow part. Livestock needs a whole lot of water, too. This is a national average, 435 gallons of water to produce a pound of beef. Certainly probably a little less in the east, a little more in the west. Cows that aren't nursing, 8 to 10 gallons daily. And then, of course, when they are nursing or pregnant, up to 15 gallons a day. So they need a lot of water. And, you know, if you drive around the west or you're out hiking, and actually probably in the east as well, you see some cattle tanks that can have pretty poor water quality, especially late in the season or it hasn't rained in a while. Minerals concentrate as water evaporates. But the big thing is cows, you know, they're not using the potty. They just pretty much go wherever, including into the same water that where they drink. They also get bogged down and die. I was at a cattle tank on the Stock Pond, same thing, on the Tohono Reservation, and there were 5 cow skulls sticking out of the mud. That's a common problem with stock tanks. But the big thing is they stir up the bottom, and the fecal organisms are bonded to silt particles, and they drink that and get sick. So this is the part, if you're working in range or if you're talking with ranchers, obviously, we know they're not putting water out on the landscape for bats. They're trying to make a living running cows. And there's a lot of good animal husbandry data from the state schools that show that the cleaner water is, the cooler it is, the more cows will drink. They've done some research. They would increase the salinity of drinking water. Heifers reduce their water intake accordingly, which would reduce feed intake. So I just did a little calculations there, but if you just take a 500-pound calf and look at the differences in weight gain between clean and dirty water, and then times that by 100 calves, that's about a $5,000 difference. So should it be too hard to convince your permittees or ranchers, if they don't already know, that cows actually prefer cooler, cleaner water, and they'll gain more weight with that in mind? So that is one reason that you see troughs on the landscape. Usually they're coming from a line, a pipeline from a well, and that pipeline is often buried, so it is cooler water. And again, there's research showing that if they had access to cool water, they would gain up to half a pound more per day, because they're drinking the cooler water, and it makes them forage and eat more. They have more of an appetite. So again, this is something that information that should persuade the range side of things to make sure that the cows and bats have good, clean water. All right. Now the problem is brought to our attention, as Stu mentioned about 8 years ago. We were getting a lot of reports of bats drowned in troughs in the West. And not just bats. Honestly, raptors, birds probably have a much higher, greater mortality rate than bats, but certainly there were places where a lot of bats were found in troughs. And a little nonprofit, Red Willow Research, Rocky Mountain Bird Observatories, Prairie Partners Program, some ancillary research by Utah State University that was not looking specifically at this, but noted all these species that were drowning in troughs. And there's some spectacular examples, an entire family of Ferrigno's hawks, greater sage grouse, which are obviously, on the cusp of listing in many places. Lots of sage grouse dying in troughs, but things like white-tailed deer, golden eagles, bobcats. And we started to then, this is really why we formed this Water for Wildlife, to find out what was going on with the troughs, and to find out what could be done to make these troughs safer for wildlife, better for wildlife, and of course bats. And so that's the main objective of the project originally. And we also wanted to know, what size trough do they need, what water level, how does the configuration, how do these things affect bats? Take all this information that we gather and produce a handbook, and that handbook is out there. At the end, the resources we'll mention is that it is available on our webpage. It's just been revised. And yes, Marcos, I will send you 200 copies. I'm behind on that. I'll give you a shout here pretty quick. That's Marcus Miller out in the technical center there in Portland. And we did just revise it and update it. And then really just getting technical assistance out to ranchers and range managers. And we've been doing that with cattlemen's associations, with ramp building days, with presentations at range meetings, and workshops and training. So that's been going pretty well. We've gotten through to a lot of people. And I must say, I think already in the last 7-8 years, I get reports all the time from people that find these, they're out on the range and they're finding troughs with ramps in them and wildlife escape ramps that never had them before. Excuse the dog. Sorry about that. Can't control that one. Okay, and then, where we've been going now really also is looking at water sources for bats and wildlife at a landscape level, and not just springs and cienagas and wetlands, but also these livestock water developments like stock ponds and troughs, because, again, these are, wildlife is not distinguishing between the two. All right, so what we found out of the 570 troughs that were inventoried by us, STU, NRCS, BLM, Forest Service, and reported to us on a form, was that about 10% of them at that time, so this is about 7 years ago, had a functioning wildlife escape structure. You can see a board up here and 3 dead passerines. They didn't figure that board out. Here's in the center is a really nicely done ramp done by a rancher. Actually went into a lot of trouble and welded it, attached it to this tire trough, and the bat's swimming right underneath because it doesn't meet the size of the trough. Here's a dry trough, but even if it had water, it's very easy for animals to get trapped underneath. They're not, when they're panicking, they're not thinking all that much. So this was a problem. So we started looking around, and I believe it was a rancher that I first heard about, but I'm sure other people came up with it. He was up in central Colorado, Carville, looking at what we need to do for wildlife escape structures that would work and that would be easy. And we actually did some experiments with bats. We had 3 different flight morphologies, so 3 different, kind of sizes and wing shapes of bats, and we would test some different ramps, put them in the water, and see how long it took them to get to the ramp and if they could get out. Rocky Mountain Bird Observatory did this with, I believe, a pigeon hawk as well, a rehab hawk. And what we came up with, it's never really one size fit all, but this was the easiest thing that could be done that was inexpensive and seemed to fit many situations. So it was this expanded metal escape ramp, but the bottom line was whatever you used, it just had to be firmly attached so livestock or cows wouldn't knock it into the water. It had to meet the side of the trough because animals swim along the edge, non-rotting or last as long as possible in water of different pHs, and graspable, something animals can grab onto, and not too steep. If it was too steep, it might be hard for some animals to get out. So those were the things: firmly attached, meeting the sides, something that would last, nothing too steep, and of course something that was relatively inexpensive. So if you took a 4x8 sheet of this half-inch to 3/4-inch mesh expanded metal, flat expanded metal, you can make 8 of these 2-foot by 2-foot squares. Ends up costing about $8 or $9 a piece. They're going to last for several years, 5 to 10 years. So really no financial reason not to have these. You really should not have any steep-sided troughs on your management area or on any project that you are funding. And Stu will talk to it later, but I know it's in the conservation practice standards now without some type of an escape. On these long rectangular powder river-style troughs, just a flat piece of expanded metal kind of on a frame from the top down to the bottom. Now, reaching the bottom is important, and we'll talk about it in a minute, but if water level drops below your ramp, it's not going to do you much good. There are some companies now that are selling troughs that have ramps integrated. This is Willard Brothers out of Amarillo, Texas. You can cover your float valve with this, and wildlife, birds can land and walk down and get a drink of water. It meets the bottom of the trough, so it doesn't matter how deep or shallow it is. All right. Now, there's, as most folks know, there's all kinds of stuff out there that people use. Old boilers, tires are particularly common. The important thing is whatever you use, you just got to make sure it's meeting the sides. Now, you can take those metal ramps and you can cut them as such that they'll fit under the bead, that recessed part of the tire, and still work. Or you can use rock and mortar. It's heavy, but, rock, there's plenty of rock around normally, and it's inexpensive, and it'll look great. This is a company out of Montana. I think it's Bull Tough Troughs, and they'll sell this insert, which is a fiberglass ramp, and this actually did work. It would be better if it was something that would intercept wildlife swimming this way, but this did seem to work. All right. Now, this is a challenge. We really haven't come up with anything that works great in these, but these are extremely important to bats. These are large, open-top storage tanks. They're usually to hold water temporarily, then it's sometimes there's a little tank on the side they call a blister tank for the cows to get to, but this is then piped out to a more accessible site. It's just for storing water. People are going away from these because they do lose a lot of water to evaporation, evapotranspiration. But they're extremely important to bats, the ones that are out there. This one up in House Rock Valley, there was probably 12 species of bats, several hundred bats drinking at this. I think it kind of became a social site, a pickup bar or something as well. There was a lot of social interactions going on. But they're really hard. This one in the Chiricahua Mountains in southeastern Arizona on the Coronado National Forest only had about 8 inches of water in it, and there was at least a dozen dead passerine birds in there. This one's big enough where small bats can get in there and drink, but any other wildlife that gets in there might have trouble getting out. Now, that escape ramp, if you cut that 4x8 sheet in half, you can get one that's 44 inches deep, about 3.5 feet deep. Now remember, if your water level stays up, then that's fine. Concrete blocks stacked up like steps are another thing that I've seen the NRCS use in southern Arizona that seem to work pretty well. But this is a tough one with these storage tanks. I say you either want them to be dry or you want them to be full to the top and have a ramp. Because even at 18-inch, that standard ramp that I talked about, you make 8 per that sheet, those are about 19 inches tall. But if your water never, falls below that, then you're still in good shape. Okay, obstructions and obstacles. Now, Stu is going to talk a little bit more about this because he has some special information since he did research on this. But basically, if you're drinking on the wing, depending on how maneuverable you are as a bat, you really need to have open water to drink at. Now, so many, more than 50% of the troughs that we looked at had obstructions over the water surface. And yes, these are for managing cattle, so they won't get in a trough, knock the trough over, bracing. Most common thing is using a trough between two pastures, you can see on the right, to give livestock water in both pastures at the same time. So we know that these aren't put out there to water bats. They're put out there as a livestock management tool. But there are some things that could be done that will easily meet those livestock management objectives and make a huge difference in accessibility by bats. Probably the most important would be with these troughs that are bisected by a fence is simply removing one or two low strands, this lower bar, lower wire, and at least the more maneuverable species, we'll talk about that in a minute, can swoop underneath there to get a drink. And you just take off as much as you can so that you're still comfortable that calves won't be able to move between pastures. So you're meeting your livestock objectives. These braces probably don't need to go across the surface of the water. So the vertical braces would be good enough to keep that trough from getting knocked over by livestock. But if you do want to put braces across, just separate them as far as possible that they still meet your objectives, but leave as much water open as possible. Here's some wires stretched across. Those are basically like tripwires for bats, just to dunk them in the water. All right. Okay, so this one on the left, you can see the posts are coming up even with the top of the trough. They put a brace below the water line. I know a rancher that did that, but I don't think too many people are willing to go to that much work. I think you could just separate those braces. Now this thing here, this is a 12-foot trough, and you put it between two fences at 6 and 6 on either side, just offsetting it 2 feet. So you had 8 and 4 could actually make a big difference. It doesn't cost anything to do. Cows can still get water from both sides. Here's an example. This is also shows an access ramp made out of mortar and rock. This is on Sarah Barker's ranch in southern Arizona, the Rainbow. I can't remember the name of the allotment. But basically, they purposely offset that tank so there was more unobstructed water. They probably could have taken a couple of these crossbars off, too, which would have been better. All right. And I should mention, too, when we talked to one thing I didn't mention earlier about wildlife mortality, some people will say, I've been checking these troughs and I don't see that many dead animals. But it really is a combination of during drought, really high temperatures, and when most of the water in the area has been captured for livestock troughs. So something I felt I better say. Now this is something that some folks have done, a watering corral, where they just have a removable panel, and then they can move it between T-posts and give water to one pasture or the other, or even 3 or 4 pastures. To be honest, this is almost a 20-foot diameter trough, so the 10 feet on either side, you're still in pretty good shape for most bat species. Trough placement, this is something that most people don't think about, but it's also something that wouldn't hardly cost anything. First thing, the height. You can see that trough on the right, it's pedestaled. Even calves would have a hard time drinking there. A lot of people don't like to countersink troughs, sink them down low in the ground because they don't want the livestock stepping in. They're afraid of them falling or defecating the water. But what's interesting is I've been through entire regions and states where people have 1 or 2 foot sides on their troughs and don't seem to have any problems. I think it's just kind of what people do, what other people have done before them, and I don't really know too many instances, very few, of livestock hurting themselves stepping in a trough or calves drowning in a trough, getting turned upside down. I hear that. So if you can just get that height down, think back to that picture with the javelina. That young javelina definitely could not get to water. That would make a huge difference. Orientation, this is a little more of an art. That's when they're coming in to drink, they line up just like pilots at coming into land at an airport. And if you know you always have a crosswind, just turn your trough into the wind. It'll make it easier for them to drink. Also, don't tee a trough along this long axis, an oval trough or a rectangular trough. Don't tee it into a fence, because then the bat will have to pull up and probably will have a hard time drinking several species. Just make it parallel to that fence. Same with trees or other obstruction. So if you can, just by changing the orientation of that trough, doesn't cost a dime, but it can make a big difference for the bats. All right, we talked about maintenance. Again, when people move cows between pastures, they often turn water off if they have water that has that ability. And if you do this in April or May, when there's a lot of animals that are wildlife that are pregnant, lactating, and are relying on that water source, you can certainly knock out reproduction for that season, if not longer. So, one, by having your trough full to the top, it makes it easier to get to. The sides don't become an obstruction as the water gets lower. Two, you know the water is there at critical times of the year when they need it, especially as we mentioned in drought and during reproduction. And, if it stayed to the top, if your water was full to the top all the time, you might be fine without an escape ramp. I mean, I would still recommend putting one in, but the animal could simply swim to the side and get out. Now, Rocky Mountain Bird Observatory has recommended full or empty. If it's going to, some people will fill it up and then turn the water off, but keep it full when they move the cow so that it slowly evaporates away. The idea is leave some water there for a while for wildlife. But if you don't have an escape ramp in there, then you're just creating an entrapment issue. You can see that center picture. There's a ramp, but obviously animals can't get to it. On the right, there's algae all across the surface of the water. The bats were all coming in to drink at that one little open water. Algae could be mechanically removed. People use goldfish. You definitely don't want to use those in any systems where they can get out into a natural watershed. They also get eaten, of course, by herons and such. And one other thing from decreasing algae that I noted, Pueblo Santa Ana, north of Albuquerque, was putting blue food coloring. This is for livestock purposes. And the reduction in solarization, the decrease in sunlight, kept the algae blooms down. So if they were buying that at a restaurant supply house, but it was a dark food coloring. So kind of neat. Now, I'm going to show a video. I think it's the next slide. I'll check. Yes, we were looking at how water levels affect that access coming in. So I think the moderator is going to pull up the video. And what you'll see is a video of, it was shot with a thermal imaging camera out in House Rock Valley. And we filmed for 5 nights with the water full in this trough. And then we reduced the water level 12 inches and filmed again. This is another place that Stu is doing his research as well on obstructions. And the sounds you're going to hear, there are 2 different bat detectors going. They're just electronic equipment that pick up and translate the sound of the bat so you can hear them. And so you'll see when a bat gets a drink, you'll see a little ripple. When it doesn't get a drink, you won't see a ripple in the water. Now, this is just a few minutes at a trough up in the House Rock Valley of Arizona. There are sites where you had 500 passes to water in 15 minutes. And there was other good water in this area. So this is just giving you an idea of how important these troughs are to bats in certain times of year and certain areas. And, if there was 300 pronghorn coming to the water in the daytime, you would definitely notice it. But if you have 300 bats coming to water over 20 minutes at night, unless you have a bat detector, night vision equipment, or a flashlight, you're not going to know it. Moderator, I'm going to hand it over to you and see what's going on with the video. Oh, there we go. Okay, you can give it back to me. So when it was pulled to the top, there were 3 successful passes to 1 unsuccessful pass. And when we dropped to 12 inches, there was 1 successful pass but 3 unsuccessful passes to water. This is about a 14-foot long by 3.5-foot wide metal trough. With the thermal imaging camera, the warm things like the water of the bats are dark, and the cold things like the steel are light. Should we play one more time? One more time. Just because it's cool.
Happy to, Dan.
All right. Now,
Perfect.
good? All right. Okay, so I'm going to finish up with just a little more than a dozen slides, wrap this up, but there's still a couple more important things. And then we'll have Stu will talk, and then there'll be some time for questions. Okay, now are we switching back to the main slide? The main presentation, part 2, moderator?
Yes,
Here we go. Double click. That's good. Okay, so this is a question we get a lot, which is, well, how big of a water do they need? And the answer is it depends on the bat species, because with there's a big difference in flight morphology. There's some fast, high-flying bats like the Mexican freetail or Western Mastiff bat, and they need really large body of water before they can swoop down. And a few of the Myotis bats and maybe the pallid bat, they can get by with a much smaller body of water because they have more maneuverability. Just think of the difference between a hummingbird and a peregrine. So what we did, we tried to do some experiments, but it was pretty difficult in the field. So we ended up looking at about 25 years of data of bats that were captured at known size waters. And we had enough information for maybe 16 species where we could make some generalizations. And what you need to know, the take-home is that troughs in the 10 to 15-foot range, they culminated twice as many species, 8 of the 16 that we looked at, as troughs in the 6 to 8-foot range. That's either 6-foot diameter, unobstructed, 8-foot, unobstructed. So if you look here on the left, there's a number of species, 4. We recorded consistently 4 species drinking in that 6 to 8-foot range. And then when we went in that 10 to 15-foot range, we had 8 species. So that was the biggest jump from 4 to 8. Now, there are some species, 2 or 3 species, that need 50 to 100 feet of water. Now, we're a little less concerned about them because they also happen to have huge home ranges. They cover maybe 100 square miles or 50 square miles. So they're going to find a reservoir, a stock tank, something big. But those bats that are smaller, or at least have are a smaller home range, a lot of the Myotis bats, and there's some bats in between, big brown bat, silver-haired bat, red bat, where this difference between 4 feet and 8 feet diameter makes a difference for them. Now think back to that trough that was bisected by the fence. So there's where the 6 and 6 on either side of the fence is not the same as 4 and 8 or 2 and 10 for the bats. So another take-home for this is if you have money to put out in range, to put out an 8-foot diameter trough, your standard metal ring tank, HW brand or whatever, and you can get an extra $50 from Widlife to put out a 12-foot trough, you would be doing good. Okay, access ramps. This side used to say pro and con, but I really can't think of any con. This is just getting animals up to the trough to get a drink. That's Sarah Barker again. She put, and it was in an earlier photo, well, there it is on the right here, a rock and mortar ramp coming in, and these Chiricahua leopard frogs, which are endangered, actually started a little population in this tank. They've been there for 3 or 4 years now, maintaining a population. They probably come and go between the draw when there's water over there in the ephemeral stream. But the important thing is if you provide an access ramp, you have to make sure that your ramp to get out is in as good shape because you don't want to create a trap. The bottom right here is a Quivira Coalition out of Santa Fe, has a little ranch, Red Canyon Ranch, and they have a big storage tank nearby. And this was a small trough, ostensibly for livestock. I'm not sure. I don't think they're grazing it right now. But I watched a skunk climb up a couple tires they had piled next to it and some span of metal. And he spent 20 minutes drinking out of this trough. Stu has a picture of a dead skunk in a trough that looks like it had been there a while. And I can tell you, I would probably die before I would have drank out of that trough, but cows were having to drink out of that trough. So I think an access ramp is a good idea. I think it's, again, if you can sink your trough down a little bit, I really don't see the problem. As long as if you invite animals in, you got to just make sure that the material that you're using in and out are the same so one doesn't rot out and the other one is still there. The last thing, and this is really where I've been spending the most of my time the last couple of years, is dirt stock tanks. And this is a talk, and this is a section that really could be just as applicable to range without wildlife. But besides the poor quality water, many troughs, stock ponds in the West were just dug out with a dozer, and the spoils, the excavated material were pushed up to make a dam. Of course, these are catching surface flow. They're usually in the drainage. And they often go dry. When you find a big stock tank that holds water, besides having a large catchment area and a large volume of water, I can almost guarantee you the reason it's holding water year-round, besides those first two factors, is that there's good clay. There's a relatively impermeable layer. The term is aquitard, holding that water in, and the dam was constructed well. Well, that's about 5% of the stock tanks that are out there on the landscape. Now, in this case, too, this was an NRCS-funded project on the San Rafael Cattle Company. He got money, Ross Humphreys, to put in 4 new tanks or restore 4 old tanks, and the water is pumped from a well into these storage tanks. Part of it is pumped into this stock pond, and part is pumped outside an exclosure to the livestock. And the stock pond has endangered Sonoran tiger salamanders, Gila chub, and Chiricahua leopard frogs. So it's an endangered wildlife habitat. He has a safe harbor agreement, but he created those waters for wildlife, and then the water is also getting pumped out. He got 4 new water sources for his livestock on that ranch, and that was back with probably EQIP, not WIP funds. I know some of that stuff is changing. Stu might talk about that. But so stock ponds, really, you can make them hold water longer, and you can make them make better wildlife habitat, and then you can manage livestock to the stock pond. Here's an example. Dillon, Montana, in July, they fenced off the stock pond. You can see the dam, and then they're piping the water out to this trough here. The livestock are getting better water. They've created a really nice habitat here. My camera corrupted the pictures from the summer, but there were ducks on this and some good vegetation. And it doesn't mean you can't graze it. You have a fence with a gate. It just means you graze it occasionally and at the right time of the year. And that's actually important, too, because if you're fencing off a spring, you're fencing off a stock pond, you don't want it to be completely covered up with vegetation, and that will happen, at least as a biologist. You don't. All right, this is Alameda County in California. They've been working. They have about 700 stock tanks that they've worked on private land. This is NRCD and NRS. In this case, they fenced half of this tank because the red-legged frog likes the hide and cover. The California tiger salamander, which is endangered, actually likes a trampled area. Its larvae like for lack of a better term, a beat-out area, and the cows are still getting better water. Now, there's one other thing they could have done here, which I'll show you in a minute, which is create a ramp to the water, a rock ramp, and just give the cows access to that and nowhere else. I'll try and do this one quickly. This was a spring on the Navajo. Top right, you can see how nasty this water is and how beat out it is. This flowed about 300 feet in a seep. This is just 1 gallon per minute coming out into a 40-foot diameter dirt tank. It was actually in good clay. It was holding water, but it also had that constant supply. So obviously, a lot of stock tanks that are getting surface water don't have that. So what you need to do, the basic technique when you're using surface water is if you have clay, it's a question of the water has to be out of the tank, it has to be moist, is compacting that clay. So you're taking a dozer, you're pulling that clay out, you are putting it back in 6-inch layers after you have designed the tank or redesigned the tank how you want it. It could have wildlife habitat, it could have an island, it could have bays. And then you compact that clay. Now you will not lose water through the bottom. We'll come to it, but you'll also build a core trench, a dam, an underground dam, and compact the clay in that dam at the base of the existing dam to hold water. Now, I'll be perfectly honest, I don't know how NRCS conservation practice standards, if they will allow this or not. It's a good discussion topic, but there's no question in my mind that an awful lot of stock tanks out there can be made to hold water a lot longer with some pretty basic techniques. Now, on this one, bottom right, we doubled the size of the stock tank. We excavated it, and then we compacted the clay, and then we're breaking through. And now you see the bottom left. We've doubled the size of the stock tank. This load of rock is going to be a cattle ramp. Geotextile fabric underneath, and 1.5-inch dirty rock from the quarry. And now the cattle will only have access to the stock pond at that ramp. They'll get a drink and they'll leave. The rest of the entire area is fenced off, and that stock tank has become a really good wildlife habitat for all species of wildlife. And it's a win-win situation because these cows had lost 20%. It was a bull pasture of their weight from drinking contaminated water. And now, the bottom right, you can see the livestock ramp. Now, the fencing had not been done in this picture yet. The dam did not need to be so high, so we brought the dam down to about 5% slope. It causes less erosion problems. And the top left, you can see that spring area. It's all been cleaned out. Before we left, we mucked out this seat that went between the spring and the stock pond. So this is $2,500, this project, and created just excellent wildlife habitat. All right, I'm going to finish with wildlife water development. It's something basically just saying that, as we talked about with troughs, bigger and longer is better. This was white sands missile range. These were little drinkers put in for ungulates, 1 foot square. They've replaced those with an 11-foot or 12-foot diameter fiberglass trough. That float tank is here, protected, sunk and protected, and much better for bats. The reverse, bats cannot drink out of this, nor swallows or nightjars, but they can drink out of this, and pronghorn and deer and elk can drink out of both. Here's a 4x4 drinker in Cabeza Prieta. So 4x4 is 16 square feet, but 4 feet either way, greatest single dimension. 2 foot by 8 foot is still 16 square feet of water, but now you have an 8 foot long drinker instead of a 4 foot, and you will do better for bats with that. So that's pretty straightforward as well. In summary, let's see if the summary slide works. Yes. You have to have properly designed and placed escape structures, and where possible, minimize obstructions to the water surface. The larger and longer and least obstructed the trough or wildlife water development, the better for bats. Try to maintain consistent water availability and full water levels, especially during maternity season and drought. And dirt tanks can be made to hold water longer so it's available at critical times. Fencing can be used to manage cattle use of these stock ponds and springs, improving wildlife habitat and water quality for livestock and wildlife. This also reminds me that we are also doing this work with springs, where springs have been heavily impacted. There's very few springs in the U.S., east or west, that people haven't tried to get water out of sometime over the last 100 years. And we are creating open water at these springs, pooled water, and then we are fencing that area off for wildlife, and then we are either piping or providing limited access for livestock so that they can still get water that's good quality, and then we can preserve the value of those springs. And that really is something in the face of climate change and less water on the landscape, can we really afford to provide separate waters out on the landscape for livestock and for wildlife? I would say no. I think we should be providing water for both. Oh, that's interesting. We get the slide twice. Get through it. I think there's one more. Oh, and the NRCS folks know, obviously, EQIP and WIP. You can also pool money with Partners for Fish and Wildlife who can work on private land. I know a lot of NRCS and Partners people work together. There's also, of course, all the other groups, National Wild Turkey Federation, Elk Federation. There's a lot of people out there that are trying to put better water on the land for wildlife, and I would suggest the range and the wildlife folks in any shop work together pretty closely. And that's it. When we send the information out, I will send a link to our Water for Wildlife handbook that was just revised, and that is available at www.batcon.org. And then you look under what we do, and you'll see the Water for Wildlife project, and there will be a link to download that handbook. We should be able to get some hard copies out if we can pretty soon. And also a book called Wetland Restoration, and let's see what the proper title is. Hang on. So I had it up. Here we go. Wetland Restoration and Construction, a technical guide. So write that down, or we'll make sure Bill gets it out with this presentation. It's recently put out by a Forest Service employee who's been doing this for 30 years, and basic information on restored pooled water and wetlands using clay, surface water, liners where you don't have clay, and building groundwater dams, and some pretty basic techniques that work really well. Okay, let me get this back over to Stu.
All right, thanks, Dan. It's a great presentation. For those of you with us, we're only about 10 minutes from being done. I got a few things I'd like to go over, and then we'll open it up for question and answers. I just wanted to give you a real quick background on where some of this obstruction thing came from. That was in the early part of the development of Water for Wildlife, and this was what I did a portion of my master's research on. So this is one of the experiments I did. You can see a water trough, a side view of the water trough, and it indicates 3 wires of barbed wire going across the trough to split it in half. And this is just simulating what we've seen across the landscape, somewhere between 30 and 40% of the troughs that we looked at had some kind of an obstruction, and most of those were these wire fences going across to split it for 2 pastures. So just wanted to see what bats were doing with this. And so what bats could do, what I did was I put video cameras up at several different troughs. Some did not have obstruction, some did. I'm just going to concentrate on what we saw in the obstructions. So bats could just go swooping by, and I couldn't tell if there was any kind of interaction. So that was one category. It might run a little bit slower from my end of things because I'm on a different system. But another thing that bats could do with this modification is place is they could be approaching the trough to drink out of, like the lower right bat, and they see the obstruction or they detect it with their sonar and they fly away without accessing the water. Or they could be flying towards the obstruction and alter their path to swoop over it. Either case, they're avoiding the obstruction, but most of the time they're not able to get water in that case. And a lot of times I had bats just fly right in between the wires and fly away. I didn't know whether that was really, they were just lucky to miss the wire, or they saw it and they flew in between. And of course, this is what I was really interested in. If we put obstructions across the troughs, do we have bats hitting the wires or the posts on the sides and either hitting them and flying away or actually falling into the water? And the question was, do trough modifications cause bat injury or mortality? And here's the basic results of that particular experiment, was that about 15% of the interactions, I couldn't tell whether they really interacted with the modification or not. Only 1.5% of those flight approaches by bats actually made contact with the wires. And only a percentage of them, about 10% or 2 or 3 of them, actually hit the wire and then fell into the trough. All of those were able to swim to the side, and because it was a really rough-sided trough, they were able to climb out. Some of them, about 3.5%, went in between the wires, but the vast majority of those interactions where I could tell that the bat was interacting with that modification, it was an avoidance procedure. They altered their flight path to either just turn back around or go over the top of it and fly away. So, yeah, some bats do make contact with modifications, and there is some potential injury or mortality. Might be some of the explanation for the bats that we did find found in troughs. But the bigger issue here is that even if they're not contacting with those wires, they're having to avoid their flight patterns, and that's increased energetic costs to fly in several times in order to get a drink, or it may be preventing them from drinking at that trough altogether. So that was kind of some of the early stuff and how I met Dan, and we worked together on a lot of different things. And it led to a lot of the results that Dan talked about over the last hour. One of the questions that came up early in this, when we were proposing taking this information and changing our NRCS practice standards for water troughs to be safer for wildlife, is we heard a lot of comments, or at least I did, that, well, this is just an issue out in the southwest where it's arid and there's not much water. Out in the east, there's lots of water everywhere, so it's not an issue. And we haven't really done any experimentation on that, but this is just some observations. The trough on the left is only a half a mile, it's less than a half a mile from that pond that's down on the bottom just below it. And yet we did some of the experiments on that same trough right there and had a lot of bats flying in, and we only had one species of bats using it. And it was a very maneuverable bat, Myota cereolabrum, can almost drink out of a teacup, and so it had no problem. But the other bigger bats and less maneuvered bats, they couldn't even access the water there. Here's another trough in the middle. There's 3 dead bats floating in there. There was also a couple of chuckers floating in it dead. And that's a view from the top. If you look at it from the side, that's the bottom picture. So it's only about 30 feet away from a fairly sizable pond, and yet wildlife were using that trough. And you can see the dead bat floating in there in the picture of in the upper right. I've also looked at a bunch of troughs out around the country, not near what Dan has. There's a trough from Hawaii. I took a picture of it on Molokai. There's riparian area in the background. There's all kinds of ponds and open water around that trough. And yet there was some dead birds that I was told they just fished out of there the day before, and this was on Nature's Conservancy property on Molokai. So we haven't done those experiments out in the east, but I think this indicates that like Dan said early on in his presentation, the bats and other wildlife really don't care whether it's a natural water source or an artificial water source. It's just open water, and they're going to go for it. And so even if you have a pond next door, they may be flying into a trough that has wires across it, fencing, etc. So they still should have escape ramps. So prior to 2004, there was really little reference to wildlife use and safety in the original 614 trough standard. At that time, we had a different standard for wildlife troughs, the 648, and it did not really account for animals that must drink while in flight. There were some discussions, very vague ones, about making it safe for wildlife to remove hazards, but there really wasn't any kind of guidance in there. So I think that's why we had a lot of the troughs, like the ones you saw there at the bottom of that slide. What has happened since 2004, basically 8 years later? This is some excerpts from the national standard as it stands right now, talking about incorporating escape features, protecting areas around watering facilities so that it's not eroding away from the trough and leaving the smaller wildlife in access. Designing the fences associated with facilities for safe access and for exit. It's a little more vague than what we have in Arizona. At least it's addressing the issue. A couple more, protecting bats and other species that access water by skimming across the surface. Don't put the fences across the water surface if you can help it. And if you have to, then using material that's going to be less of a tripwire for bats, such as a woven wire, or putting a log across to split the fence or split the trough rather than barbed wire. And one also that I'm glad to see that's been added is considering the effects of introducing new water sources into the ecosystem. We've had a lot of folks say if one water is good, lots of waters are better. Well, it's not necessarily the case for wildlife. Before European settlement, there were many large areas out in the west, especially in the southwest, where there just wasn't free water. And we've introduced water into those sources pretty much at will, sometimes at the detriment of the local wildlife. So we need to consider those effects every time we do put in more troughs and ponds. So beyond the national standard, Arizona's, and I'm sure a lot of other states have upgraded theirs as well. We've just gone into the weeds a little bit more, and we're asking people to leave water in there year-round whenever possible, making sure that it's more clear that escape ramps need to be put in the troughs. It's a requirement. It's not a suggestion. And that we are also suggesting they should be accessible to small animals, indicating that you should have ingress as well as egress. Protecting the facilities from livestock or wildlife falling into the tank by keeping it full up to its capacity is highly recommended. If the trough is full all the way to the top, then if there's not an escape ramp, it's not much of a big deal. For the large watering facilities, we're still kind of at a loss here of what's a really good design to put in a large open tank, storage tank. If anybody has ideas, we'd love to hear them. I've got several test drawings that we tried. They really haven't worked out well. The only thing we can do is in trying to put in those 4-foot expanded metal ramps and hope that the water level doesn't go down below them. I did have a question from Karen, and I see, Karen, you're on there. But last week, I think she asked, what if we went to a smaller mesh, like a 1/4-inch mesh, where it's a lot easier to bend into shape, and you don't have to have all the equipment? We'd like to test that out a little bit. One thing that we would caution is that there is some indications of raptors getting their talons caught in some of these ramps, and then they're trapped there. And I think with a small quarter-inch opening, that might be more prevalent with the raptors. But we're really interested in other ideas that folks have come up with for different designs for these escape ramps. This is basically my last one, and this is the only comment as far as water facilities and effects on wildlife that came from a recent consultation with the Fish and Wildlife Service. We did a statewide programmatic consultation on all our range practices, including wildlife or watering facility. And since we already had all that other information in the standards, they thought we'd addressed it well enough that this was the only thing they added, which is locating water facilities away from known predator perches, if you've got a T&E species that you're worried about. So I think that's kind of telling that we've come a long way. We would never have gotten that kind of consultation out of Fish and Wildlife Service. All this research that Dan has done and all the information that we've come up with. So with that, I think we're ready to open it up for questions or comments. And my last comment would be, this is what it's all about. Is it's a win-win situation for wildlife and producers. We want to keep wildlife safe so we don't have drowned skunks like this one. And like Dan says, I don't think any of us would want to drink out of that trough, and I doubt the cows were too happy about it either. So we will now open it up to questions. I'll turn it over to the moderator.
Gentlemen, thank you so much for that information. A few reminders, ladies and gentlemen. If you're connected via telephone, simply press *1 on your telephone handset to ask a question. If you prefer, you may also use the raise hand icon to ask a question in the system. With that, we're now open for questions. Stacey, please go ahead.
All right. Can you guys hear me?
Yeah.
All right. Hey, Stu and Dan, great presentation. I really thought it was one of the best ones we've had so far. You guys talked a little bit at the end, Stu, about the some of the potential negative effects of additional water on the landscape. When we're talking about wildlife troughs, that's not really something we're going to have a lot of control over when, where, and how much, but we can try to make the best of those. When you talk about guzzlers and additional water on the landscape from guzzlers for wildlife, I start to think a lot about the effects to the wildlife community as a whole, the source sink dynamics. I think a lot of people assume always across the board more water is better, and I think sometimes more water is better. Sometimes it's not as good. Sometimes it's a bad thing. I worry about effects of subsidized predators, ravens, magpies, skunks, foxes, those things, and potentially wild horses and burros, benefits to those as well. And do you guys have any studies or comments or any sort of information on how to assess this or what some of the effects are on the larger community scale of adding additional water on the landscape?
Can you hear me?
Yeah.
Okay. That's a really excellent point, and it's a really complex question. There's very little published. There's a few things, and here's kind of a quick run around with it that I know of. First thing, like when we're working in southern Arizona and we're looking at creating cold water sources for bats and Chiricahua leopard frogs, we have to be aware of not creating a source for bullfrogs, which are an introduced species. And they also don't get BD, however to pronounce it, chytrid fungus, but they carry chytrid fungus. So in those cases, you actually don't build a water unless it can be drained or unless you can provide a bullfrog fence. You have to know what's going on with your Chiricahua leopard frog recovery. So there's a instance like you're talking about where you really need to know the context of what's going on with other wildlife. I haven't read the research. I was told that Adam Kozlowski with Utah DNR did his master's on kit fox. populations, probably I would assume Great Basin since he's in Utah, and that in some cases kit fox are more they need less water. They get by in more arid areas than coyotes, and that putting waters in there, it's the mesopredator thing, allow coyotes to do better at the expense of kit foxes. So there's another example where, yes, in that case it would be a problem, or it could be a problem. Now, Steve Rosenstock at Arizona Game and Fish, I don't know how much of this he's published. He did some long-term research at Yuma in low-elevation desert at wildlife waters that were put in. Primarily was driven by bighorn sheep, because bighorn sheep and water has always been an issue. He looked at mesopredators, he looked at native pollinators, he looked at migrant versus resident bird species, and he actually didn't seem to find an effect of this increased water on any of the changing any of the community composition of the mammals. Like I said, I don't know if he's published that or not. One thing we would like to do is put together a more comprehensive book or guide to water for wildlife on arid lands for grazing, and this is definitely something that both research questions and what's out there needs to be addressed. I mean, in some cases, as Stu mentioned, we've put water out on the landscape, and I would say I don't know if there's a lot more out there than there used to be, but it's distributed differently, because we certainly eliminated lots and lots, at least in the arid west, lots and lots and lots of springs, cienagas, riparian areas, perennial streams that were perennial or intermittent that are now intermittent or gone or ephemeral. So, we probably still might have a net increase in water, but to me the real big thing is how it's distributed. It's definitely it's no longer tied to a drainage feature or a geological feature when you're drilling a well and putting water out. So yeah, those are good, really good comments, and probably anybody putting water out for wildlife. Also, disease transmission. There's been concerns about that. Anyone putting water out for wildlife should probably do at least a cursory analysis of potential, negative deleterious effects. So that's obviously not a specific answer, but it's good that you brought the comment up. It's something that needs to be thought of.
Yeah, I'd add to that. Good question, Casey. In Arizona, our wildlife habitat evaluation does have some questions related to it. We want people to look at what was the landscape prior to settlement and determine, is there some lost water sources like a spring or a riparian area that used to be perennial, now it's intermittent or even ephemeral, that creates a need for additional water, or are we just putting water out there just to put water out there? And we just want people to think about it through that process.
Thanks, guys.
Sure.
Excellent. Thank you for that question. Ladies and gentlemen, for those on the line still, once more, a quick reminder that *1 on your telephone handset or raised hand in your webinar software will place you in queue for questions. Gentlemen, however, at this time, I'm not showing additional questions in the queue.
Okay.
Again, and Stu, this is Bill Holman speaking, and I just want to thank you for an excellent webinar. And I think we had a good turnout today, and I think that this recording is one that people will want to view and distribute. Thank you very much.
Thanks, everybody, for tuning in today. And if you have any specific questions on bats and water, you can always reach me at detailer@batcon.org.
I got one for you, Dan. What's your area of coverage? If people in the East wanted to get you out for some work presentations, are you open to that?
Yeah, absolutely. We really are going to start looking at water, period. Obviously water has become such an issue. It's in the Southwest it really pops out because it's a huge issue everywhere. But globally it's an issue, and nationally it's an issue with drought, changing climate. So, yeah, absolutely. We would love to hear from people and learn about the situations in other areas as well.
Well, I don't see anybody else either, so I guess we can close shop.
This is Bill again, and as Dan mentioned, there are a couple references that he will make available to us, and we will provide those links and perhaps copies on the Biology SharePoint site for people to access when we provide information about how to download this presentation. Thanks again, Dan and Stu.
Great. Thank you both.
Yeah,
Everybody.
thank you. Everybody.
All right. Cheers.